Hi, my name is Evan. Thank you for having me here. It's always nice to have more than like 3 people whenever been in those presentations. So I'm going to be talking about a game that I love. It's near and dear to my heart, called Hunt the Wumpus. It is a classic, and I have to start off with kind of a little story, and then it's all going to kind of click and come together. So just, even though it may seem like I'm kind of going off on a tangent, trust me, it's a calculated tangent. So I teach at the Technology Center at DePage, which is right around the corner from where we used to have the venue at Heron Point. And I teach video game programming there. That's my website at the bottom, mrwrightteacher.net. I can give anybody a credit later if you want one. I generally teach 12th grade high school. Generally a pretty normal person. I have a job, a wife, 2 kids, 3 dogs, and by most accounts, it's okay, except for the vast amount of retro hardware I'm now accumulating. Most people would say I'm fairly mainstream. I will now just invalidate that statement by saying that I'm really obsessed with text adventures. And if you haven't seen Jason Scott's movie called Get Lamp, which is free on YouTube, you should totally go watch that. So a while ago, I was presenting on a web-based system I had made for helping students write text adventures. I was trying to tell teachers why we should be using text adventures in history class and in English class and use them for creative writing. So I was presenting on that thing, and the tech guy who was helping set up the projector said, "Oh, if you love like this old technology stuff, if you love this retro stuff, you should go to the library because we had a TI-99 4A running Hunt the Wumpus." I was like, "Oh my God, I love the TI-99 4A. I totally wish I had a TI-99 4A." And then in this kind of weird, awkward moment, I actually realized I did have a TI-99 4A, and it was just a box in the basement, and I didn't have the video cable. I didn't know how to hook it up, so it did no box. So all I did was order this Hunt the Wumpus cartridge, and it's a fantastic game. Like, I set this game up on a TI-99 in my classroom, and the students love it. And these are students that have like a PlayStation at home, they have an Xbox at home. So the way the game works is there's a network of rooms, and there's a monster in there called the Wumpus. And if you wander into the room with the Wumpus will kill you and eat you. And if you have one arrow, so you have to find where the Wumpus is using process of elimination, and fire the arrow into the right room. And if you miss, the Wumpus kills you and eats you. Not sure. I guess orders are important, right? And there are also bottomless pits in the maze. So if you see these rings around these squares here, that's a bottomless pit. So there's probably a bottomless pit there. If you fall into there, you fall to your horrible, gruesome death. So every decision you make in the game is very important because it may determine whether or not you win or you suffer a horrible, horrible death. So I was like, okay, that is really cool. I love this game. So, but the TI version is not the first. It actually goes back before then. It goes back to 1972, and the original version was text-based. It was written in BASIC. Again, in Gregory Yob. I think I looked up on Wikipedia what happened to him. I think he had his head cryogenically frozen. Like, he passed away a number of years ago, but his head is in a freezer somewhere. Double check that on Wikipedia. I don't know. So there was a dodecahedral network of rooms like that. Every room was connected to 3 other rooms, and the Wumpus was randomly placed in there along with the pits. So there's several versions of this game. But what I wanted to do was kind of make like a graphic version. And then another weird thing happened. I went into the public library and I saw this book, like in the bargain rack for 50 cents. I said, "Oh my God, I gotta have that book," because I had a Sinclair when I was a kid. At that point, I know now what I must do. Like, I'm going to take, the heavens part of the ray of sunlight came down. I'm like, yes. So what I need to do is make a Hunt the Wumpus game for the Sinclair. So, but I didn't want to do it basic. I wanted to try something different. I wanted to try it in assembly and kind of reverse engineer, figure out how people used to write assembly games back on these old machines that seem like they only run basic. Like, how did they pull that off? What did they do? So just a little bit about the history of me and the Sinclair. The reason I love the Sinclair so much is because I had one when I was a kid, and this is actually an article from Sinclair User Magazine from 1983. It's somebody wrote an article about a class that was taking place in my town. This is my, oh, he's not in this picture, sorry. My computer teacher at school ran the class, and he had 2 classes, one where you build the kits, another where you learn to program them. So somehow there was an article about this in Sinclair User Magazine. So this is actually me right here, the kid with the hair and the army jacket and the hair. I always have to stress the hair. So, and that might be me up there in the top right, I'm not sure. So I have this kind of love affair with this Sinclair. It has very low specs. It's got a Z80 processor in it, which is really nice. It has the British version, which is what we had 1K of RAM. The Timex Sinclair 1000, which is basically the same thing, had 2K of RAM, black and white, no sound, but cheap, so everybody could have one. So it was just kind of a fun little computer. The specs are so low that they made fun of this computer in Futurama. I was watching an episode one day where Bender goes to the island of obsolete technology, and there's a robot there named Sinclair, and the joke is that he can't remember anything. Anytime you tell him something new, he forgets the last thing you told him. It says Sinclair 2K like on his, on his little chest plate there. Like coincidence? I think not. Right? So yeah, that's where else would you find a reference to some ancient computer? So if you're going to try to write a game for one of these really old machines, there's a couple of basic things you need to know. Like you need to know where in the memory the program is going to go. Where normally you write basic code right, for these things. So like there's an address where the basic code goes, right? You have to figure out where that is. And then what you do is you kind of sneak your assembly language in there, and then you jump into it. So the basic language has a command in it. It's either user or sys, and you give it an address to jump to. So jump. A basic program, jump to this address and run whatever you find there as machine code. So there's a way to sneak into machine code from basic. And then you have to know where the screen memory is located because it's just like basic. Like if you want to draw to the screen, you can poke a character into a particular location and it's like magically shows up on the screen because it's not really magic. The hardware designer did a good job and set it up that way. So you have to know where to keep and poke the characters in order to get them to show up. And then just basic stuff, you have to read the keyboard, generate random numbers. That's kind of all you need for a game. So how do you do that on one of these old computers? You need the manuals. These things, you get them on eBay. eBay or Amazon. They're really cheap. They're great. They tell you all the instructions that the processor knows about. So I didn't know these assembly languages before I started this project. I had taken a class in like IBM assembler like back in '95 or something. But I was able to pick it up really fast with these books. These books are great. And you need all the manuals. So because there's information in there that you're going to need to know about, like where does the basic program start, and how do you write to the screen, all those addresses, all that stuff is in the manual, so you need those. These are available, most of them you can find on PDF format online, so that's really helpful. And then you also need to know how the basic commands are formatted. You have to count up bytes at one point, and I'll show you that in a second. But so you need to find all these, as many manuals as you can. So once you have the manuals, you need a bunch of other things. You just need a text editor for writing your assembly code. And then you need something to actually assemble it. So I use Telemark Cross Assembler because it can actually do Z80 code or 6502 assembly. So you can use the same assembler for multiple projects. You need some emulator to test with. So for the Sinclair, there's an emulator called 81. For the Commodore, there's obviously WinVice, which is like a suite of programs. There's one in there for the VIC-20. And then to get the thing actually onto the Sinclair computer, you need some sort of an audio player. I use Audacity. And then, the actual computer. Right? It's fun to buy computers off of eBay, right? So that's like the icing on the cake is when you get to run on the actual computer. So kind of what I said before is that what you do is you kind of make this basic stub around your machine code. You kind of hide your assembly language program inside the basic code somewhere, and then you jump into it. So here's like a real simple example. This is like the most trivial example I could possibly think of. You create a basic program. You say 10 rem A, right? That just creates a comment with the character A in it. So you basically just reserved one character of space. And then what this does is it pokes the number, it sticks the number 201 into that character. And I'll explain like how I got that number in a second on the next slide. So the 201 is actually not a magic made-up number. It is the Z80's return statement. So all I've done is overwrite the character A with a Z80 return statement. And then I can say, jump to address 16514, which is the return statement, right? So it'll jump there, and it says, hey, it's a return, so it jumps back. And that's it, right? You've now written a machine language program in BASIC, right? So what you've done there is you have just carved out some space, stuck a machine language program in there, even though it just does one instruction, and then you jump to it and run it. So that is that's how this goes. And I know that it's a little bit, like, oh God, I gotta count bytes. It's actually not that bad. So this is the general idea, and the Sinclair, the program starts at address 16509, and then you have to count up like how much memory that particular basic statement takes up, and that's where you need those manuals. It'll tell you, okay, a basic statement has 2 bytes for the line number, 2 bytes for how long the line is, and then a token for the remarks thing, and you add that up, you're like, okay, that's 5 bytes, so I know that the character A must start here at 16514. So that's where your program starts in any Sinclair machine language program, right? And then you have this line 20, rand user 16514, right? That just jumps into the assembly code and runs the assembly code that it finds there. So you've basically hidden your assembly code inside the basic code. And then I think I just explained this, right? So how did I get 16514? Well, you have to go into the manual and add up the characters. But once you've done this once, this holds for any program you ever write on the machine. Drawing is just like basic. You just poke characters into memory and they'll show up, except the Sinclair video memory is really weird compared to other small computers. I just said this. Okay. So basically you just poke stuff into memory. The display file, the video file, is actually right after your basic program. Like it doesn't live at a fixed address. It lives immediately after the end of your program, which means as your program gets bigger, the video memory moves. I know, like I've never seen another computer like that. It moves around. So how do you keep track of it? There's actually there's a system variable called dfile, d_file, and that stores the address that you're going to poke the character codes to. So anytime you write something, it's like the address, the contents of the address in dfile plus some offset for how many characters across the screen you want to go. So that was some weirdness. And then do I have a picture of this? Good. Yeah, I could. So the other thing is that it's not just a big 2-dimensional array. It's not just a big grid. It starts with a new line. And then it's got 32 spaces for every line. And then it has another new line character. It's almost like a text buffer. So you can't just when you do your for loops to clear the screen, you have to take the new line into account. Otherwise, you're going to blow it away and weird things will happen. So again, I've never seen any other computer like that. So that's how the screen memory is laid out. If you have less than 4K, you don't even get these spaces. You just get your video file is just 25 new lines. It's called a collapsed display file. So I did not have to really deal with that though. So the keyboard is laid out really weird. Does anybody ever play the game on the Sinclair with the keyboard? Yeah. Okay. Did you ever notice how it'll say 5 is the left key, but you try the 1 and that would work too? Or the 6 would be the right key, and then the 0 would also work. It's because of the way the keyboard's actually constructed. So the keys are grouped. So if you hit the 6, 7, 8, 9, 0, they're all in this one group of section 4 right there. They're in section 4. So when you read the keyboard, it'll tell you what section the key was in that was pressed, and it'll also tell you what kind of column that key was in. So that uniquely identifies a particular key. So what was going on there? With that, I used to notice that in all the Sinclair games, is that to check the row and column, that's 2 things you have to do. But if all you need is left and right, you just check for that, which section is the key in, and then that's just as good, and you save yourself some work. So that was something kind of weird. So what you do is you call a subroutine. It tells you the row and column, and then you pass that information to another subroutine that's in the ROM. And it returns you a character. This is the only 2 things in the Sinclair ROM that are actually documented. The Sinclair ROM is it's like this black hole. I don't know what's in there. I don't know if anybody does. For random numbers, there's just some register that keeps track of how long the machine has been on. And you just look at the last 4 bits of that or something. As long as you're not creating tons of random numbers in a loop, you'll be fine. That's what I did. But I still feel like this guy. I still feel like Philip J. Fry. Because I'm okay, great. I kind of get the big picture now, but how do I actually turn this into code? And then I found this guy's website. This guy was in Ireland. He was extremely helpful to me. He's written high-res Space Invaders for the Sinclair. He wrote a really good Pac-Man game for the Sinclair. He's got all the development tools you need up there, and he's got a Hello World program that you can use as kind of a stub to just to start programming. So he's got all these, this Hello World program. Here's the comment, and then it says put your code here, right? So you just put your machine or your assembly code in there, and you're basically good to go. You can use everything this guy wrote. Because I never heard of process assembler before. And all the manuals I read, said, well, you have to write a hex loader and type in your thing in base 16 and it'll poke into memory and then you won't be able to save it though. And I'm like, oh, it's never gonna work. But then I found out about the cross assembler. So you can write your code on a PC, assemble it, and then for whatever processor you want, and then move it over to the machine. So there's, and then here's the end of the file, right? So he's got this include thing that closes that comment, and then there's your display file right there. So he kind of set everything up for you. that you need. And then to build it, there's a command line thing that you just do. You do it on the DOS prompt, hasm, and then the -80 means I want Z machine code. And, S is I want the symbol file, and you just give it the name and the source name and the output. So then it turns it into a file, and then you can load it into the emulator, and it actually works. I was like, yay! So I ran into class one day. I was like, students, look what I did! Right? And I showed them this truck, and they're working in Unity and like 3D Studio Max, and everything looks beautiful, and it's all 3D. And I'm like, look at this truck I made! They're like looking at me like I'm crazy. But you have to appreciate what kind of work went into that. And it's actually very smooth. It's just PowerPoint's not really running it very smoothly, but it actually does a scrolling background. That's really nice. So okay, so then once you've got that working, how do you debug it? Well, the emulator has got a debug window in it. You can step through a line at a time, and you can set breakpoints. And another thing I didn't know about was like the symbol table, which is called the list file. So what that does is it's great because I didn't even know where to put the breakpoints. Like, how do I even find the address of some subroutine I want to debug? I didn't know that there was this list file. And what it does is it has like line numbers on the left. It has your machine code here that got generated, and then it has your assembly on the right. So you can say, oh, okay, well, this line is at address, CD0144. So the list file was like absolutely indispensable in terms of finding out like where do I want to set the breakpoints, because I didn't know. And then what else? Okay, so now you've got your code assembled, and now you just have to find some way to move it onto the actual machine. So there is a program called Tapeutils, and it's written in Java, and all you do is you go to File menu and you select the program, the output from your assembler, then a little binary file that it built for you, and then you say convert it to a WAV file, and it will magically do that for you. And then once you have the WAV file, now we have the site of a happy Sinclair. So what I'm doing here is I've opened up the WAV file in Audacity, and I'm playing it into like the tape recorder input on the Sinclair. So the Sinclair thinks it's listening to a tape recorder, but it's actually listening to Audacity running on the laptop. And this is totally normal for the Sinclair. Apparently the wires were crossed, or they used some circuitry for two purposes, so it couldn't simultaneously run the display and listen to the tape recorder. Yeah, I know. But this actually works out really well, because if you get the lines that are about that kind of thickness, that means that the volume is set right. If the volume is if you turn up the volume on the computer, then you'll see these black lines get closer together, and you'll see less white on the screen. So you want a good balance. It tells you that your volume is set right. So it was kind of an accident or unintended design feature, but it actually had kind of a useful purpose. And then, yay, and now it loaded. So there's a little test program I just showed you. So I played it off of the audio player into the computer, and now it's loaded. And that's really cool. So how am I doing on time? Well, okay. I'll keep going. The second, this is basically the meat of it. For the VIC-20, it's going to be almost exactly the same principle. I think for like 99% of the computers out there that are running BASIC, this is probably the strategy for getting an assembly language game built. Exactly the same tools. The Commodore manuals are awesome. They're like all cartoony and friendly, and they're written for little kids. Like I have 2 9-year-olds, and they love like writing little basic programs on the Commodore. They just think it's so much fun. And so that's really, that's what you need. And then the Commodore has this thing called the Kernel, which I did not know about. I know there's a lot of Commodore guys here who are like, oh, okay, we know all this. But the Commodore has this kernel, which is basically, it's almost like a library of subroutines you can use for reading the keyboard and opening up an serial port, generating random numbers. So there's like a lot of the work has been done for you on the Commodore where it wasn't on the Sinclair. And then it's the exact same thing, except your program starts at a different address. It's 4097 instead of, I forgot what it was, 16509 or something. And then, so then I worried about this thing, the origin directive. So does everybody know this? Like, does anybody know what this is? No? Okay. I see some heads on it. Okay. So I did not know about this, right? When you make your file, you have to tell your file, you can say, I want you to pretend that this code is loaded into a particular address. And then when it generates the offsets, for your function calls and your jumps and stuff, the addresses end up working out to be what you need. So that was something I learned about. And then the basic thing is kind of the same thing, except in Commodore WAN, the machine code goes after the basic statement. So in the interest of time. So what I did was, it's the same, oh, I can't go backwards. what I did was, sorry, I put in, it's the same thing, 10 sys 4109. That's like, line 10, jump into some place and go run whatever code you find there. And then I just used a for loop to dump out the memory in the beginning of the basic memory, and then just kind of go through the manual and pick apart what that is. So you can see there's a 10 here. That's the line number, and then I think that's the token for sys, and then it's like 4109, and then a bunch of null terminators. So that's what that memory actually is. I basically dumped out the basic code, and then there it is. I put it on a chart. I'm sure this is not terribly interesting. So then basically your code goes at address 16. It's going to be like 15 bytes past the start of the basic stuff. So then the other problem I ran into was like, okay, great, now I've got this thing assembled, but how do I turn it into a file that I can like load into the memory? That's what I learned about the PRG format. To turn a memory image or into a PRG file, all you do is stick a 2-byte header on it that says, when you run this program, load it into this address. So all you have to do is stick 4097 on the front of the file, and now it magically becomes a PRG file. And so this is what it looks like on the VIC-20. So there's 4097 is the start of the basic program, and this is, you stick the 2-byte header on there, and then your assembly code goes on the end. That's how it works, right? And then you write your code, you assemble it, and it's like the same thing. Telemark cross assembler. Now you just say -65 instead of -80. It generates 6502 assembly for you, and then lo and behold, you can load the thing into WinVice. Now you have a PRG file. You go to the file menu, you select the file. Oh my gosh, it works, right? And then there's actually sound. I muted it because the audio is there's a lot of reverb in it. But now it's actually working. So now I'm playing the game that I wrote in the emulator, and I'm just seeing how many horrible ways to find the Wumpus and fall in the pits and get eaten by the Wumpus. Like that. So there it is. It's running. Right. So now the next step is how do you actually get it onto the VIC-20, like the real hardware? Well, now that it's a PRG file, why is this not moving forward? Now that it is a PRG file, Will not work with me here. I wonder if Wumpus is taking. There we go. Don't underestimate the Wumpus. So how do you actually get it in the machine? I have one of these little SD card readers. So now you just copy the PRG file over onto the SD card, and then you move it over to your little SD card reader, and now you've moved the thing from your PC onto the VIC-20. And that's it. So it's basically the same process as for the Sinclair. Your machine code is going to go in the basic memory somewhere. You have to have a little basic stub or basic harness to kind of jump into it, and then you just have to figure out some way to get the actual file onto the target machine, and that's kind of it. So, again, as I said before, that strategy would probably work for Coco or Kpro or any of those other machines out there that are running basic. I bet this is the way you do that. If you could ask me all the questions you want, but I pushed my personal knowledge to the limit here, so I cannot guarantee that I would be able to give anything that even approaches a pithy or knowledgeable answer.
Did your students do any of the programming just because they thought it was interesting?
No, they helped me out with the play testing, though. They like the play testing. No, so we do C# over at TCD where I teach. Machine code or assembly. That's outside of the scope of what we do. There would be, I don't think, a single student that I've seen the last couple of years knows machine language. But I just kind of want them to know what it is and that it exists. So I remember when I was a kid, you'd write your basic program and it would run really slowly, right? And then you'd go buy a game, load it, and it would run great. You're like, what's going on here? What's the missing piece? Then you learn about, basic is interpreted and it runs 300 times slower than machine code. But, they don't teach you the machine code part in high school, or middle school or whatever. So I just want them to kind of sit back and kind of see how it goes. And I do show them the machine code or the assembly files because I want them to see, especially those list files, because I want them to see, this is what the C# code that you write or the C code or the Java code, it gets crunched down into something that looks like this machine code that you see here, in this list file. This is the finished result of all your work, right? It's the code, the hex code that the computer can actually run.
How old are your students?
They are generally high school juniors and seniors. Yeah. So it's kind of crazy. Like, they've grown up in a world where there's never been like no Wi-Fi or multiplayer online deathmatch with over like cable modem and DSL and stuff like that.
A telephone with a cord and a wall?
I know. Literally, this is funny. I'm so glad that teletype machine was out there, because I kept running into this situation. I had a little program exercise I was showing the kids how to do, this loop, how to use a loop to compute the Fibonacci sequence, right? And it was 99 bottles of beer on the wall, like how to use a loop, and every time you go down, it prints out the verse again, but with a different number. And I know there's beer in that, there's an alcohol reference in that, but trust me, I got that exercise right out of the AP textbook, so I'm sure it was cleared by somebody. And they got totally hung up on the /r/n at the end of the sentence. And for me, I'm like, okay, /r/n, I know what that is. And then I had to explain to them what that actually is. And I'm like, okay, now when my grandmother would type me letters, she would type, and the paper would be actually feeding across the typewriter as she go. And then when she wanted to start the new line, start over, she had to go, carriage return, chunk, line feed, crank. And they're like, oh, I get it. So I actually took pictures of that teletype machine out there, because there's a button that says carriage return, there's a button that says line feed. Like, it's actually broken up into 2 separate buttons. So I'm going to be showing that to the students on Monday when I go back. It's definitely, there's a lot of teachable moments to be had around VCFF. VCF. Anything else? Yeah.
What is the video display generator in the Timex Sinclair 1000?
You just pushed way beyond that. There is a little, in the video modulator, there's a little video modulator in there. And I don't know exactly what that does. I know that's, it sends the video out. And it used to send out an RF form. And then, so you get your Sinclair from eBay, and you go and you look at it like, oh, great, my TV doesn't get BBC 3. So they're like, oh, right, composite versus RF, right? So there's actually a kit that some guy in England makes. So you desolder the video modulator, you take it out and replace it with this other thing, and now it outputs composite. But I think what you're asking is more than I know. I know there's guys that really know how to hack that, and that's how the guy in Ireland managed to do the high resolution thing. It's where you somehow trick you have to override an interrupt or something and trick the video display generator into actually running through a different line of pixels than it would normally run through, and then you have to return from the interrupt, and then it says, oh, you basically have to trick it into generating one line at a time. I don't know, but I would email the guy at perfectlynormalsite.com, or even go to his website, because he's got like a really good description of how to do it. But with me, at my level of knowledge, I went to the perfectly reasonably explained description. I'm like, okay, like it just totally lost me. I kind of followed it to a point, and then my knowledge level broke down. I didn't have the background knowledge. But the guy's out there, I think his name is Brian, he's in Ireland, perfectlynormalsite.com. That's where you want to go to get all the bootstrapping stuff to get yourself going into this stuff. It's all out there for free. Yes?
It's a trick question, because the microprocessor itself is generating the video.
Okay, so good. You can explain this to me, because I kind of want to know it.
Okay. But apparently it draws each line at a time, and then it gets to the very bottom of the screen,
yeah,
and the beam has to go all the way back up to the top and start again.
Right.
That's when it runs the basic code.
Oh, that's right, because it's got like 2 banks of registers. Like,
yeah.
So there's like the DEF, and then there's like DEF prime, and so it's using some registers to store the basic program, or run the machine language or the operating system. And there's another set of registers that's being used for the video. Because in the basic manuals, or the manuals I was reading, it says, yes, the Z80 has all these extra registers, but don't use them on the Sinclair, because the Sinclair is using them for the video.
Yeah.
Yeah.
So it's a vertical interrupt where it actually executes the basic code, not retrace each line.
Right.
No wonder it's so slow.
Yeah, it spends 75% of its time generating video and 25% of its time running code.
Sounds like that's kind of how the Atari 2600 runs this.
Yes, because that does it per scan line.
Yeah, that's right.
But I know like the Sinclair actually has 2 modes. It has a slow mode and a fast mode. So if you want to have it like crank out calculations faster, you put it in fast mode, and then it actually doesn't do any drawing. So it basically dedicates the whole processor to like processor, running your program. So, the screen will go blank, it'll run your program, and then when your program is done, it will switch back to doing the video, or it'll show you the output. So it's weird. Yeah, there's 2 modes on that thing. There's, like, why is there a fast and slow button? Why would I not always run in fast? Like, why do I really want to run in slow all the time? Like, it's kind of counterintuitive.
Yeah, out of curiosity, did the sync line have any way of, if you were writing machine code, could you have it just show one line of stuff on screen and otherwise use the rest of the frame for?
Again, like, that's kind of beyond my knowledge. I know the guy who did the high-res Space Invaders, like, he would, you could have it high resolution up to a point, and then you could have it switch into back to standard resolution, back to the standard character-based stuff at the end. So you could kind of do a split screen thing. But that's like, this was kind of an intro to assembler for me, or assembly language for dummies, and I didn't really, I was happy with my moving truck. Like, I was like, yes, I feel like God now. When he's programming a Sinclair, and I didn't really push it much beyond that. Are we done? Okay. All right. Well, thank you. Thank you very much.